Good day everyone, I am Jason Ray Cosicol of Group 1 from Section ROMEO, and I'm going to report all about the Fibonacci sequence. Today, we're going to explore what is Fibonacci sequence, how the Fibonacci numbers are obtained, how does Fibonacci sequence work, the history of Fibonacci sequence, and the Fibonacci sequence that can be found in nature. Now, let's start. What is Fibonacci sequence? Fibonacci sequence is a series of numbers that follow a unique integer sequence. So when we say series of numbers, kung sa Bisaya pa mao ni ang pagkasunod-sunod sa numbers nga naay unique or talagsaon nga integer sequence. These numbers generate mathematical patterns that can be found in all aspects of life. The patterns can be seen in everything from human body to the physiology of plants and animals. So, based on that, we can say that the Fibonacci sequence is everywhere. Makita nato siya sa atong environment, labi na mas makita nato siya sa atong kaugalingon na lawas. Fibonacci sequence is derived from Fibonacci numbers. So, sa next slide, makita nato what are the Fibonacci numbers para masabtan nato ang Fibonacci sequence. How does Fibonacci sequence work? The Fibonacci sequence is as follows: 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, 233, 377, 610, and so on. As a rule, the first two numbers in the sequence has to be 0 and 1. All other numbers follow the rule of adding two previous numbers in the sequence. Example, 1 plus 1 equals 2, 2 plus 3 equals 5, 5 plus 3 equals 8. Every third number in the sequence is even. To prove that, let us look at the Fibonacci sequence sa taas. So, there are 2, 8, 34, 144, ug 610. They are all placed in the third number of the sequence, and they are also even. Hence, every third number in the sequence is even. How are these Fibonacci numbers obtained? These numbers are obtained by adding the two previous numbers in the sequence to obtain the next higher number. The numbers are obtained from the formula Fn is equals to Fn1 plus Fn2. Mo to ang gibuhat kay no sa Fibonacci number, magsugod siya sa 0 plus 1 is equals to 1, 1 plus 1 equals to 2, 2 plus 1 equals to 3, 2 plus 3 equals to 5, 3 plus 5 equals to 8, so on. So kung ipadayon to nato nga pattern, makahimo ta og Fibonacci series. What is the history of Fibonacci sequence? The exact date of origin of Fibonacci sequence is unknown. It is believed that contributions to the theory began in 200 BC by Indian mathematicians whose studies were based in language of Sanskrit. The sequence was introduced to Western European mathematicians in 1202 by aka Fibonacci, famous as the Leonardo of Pisa. Fibonacci popularized the Indo-Arabic numeral system in the Western world primarily through his composition of Liber Abaci, or the Book of Calculation. His study of sequence began with the breeding patterns of rabbits, in which he found rabbit generations duplicated in accordance with Fibonacci numbers. Before ta move on sa next slide, ilailahon sa nato kung kinsa nang naa sa picture. The person on the picture is Fibonacci, also known as Leonardo Bonacci, Leonardo of Pisa, or Leonardo Vigolo Pisano. He was an Italian mathematician from the Republic of Pisa. He is the most talented Western mathematician of the Middle Ages. At this point, we are going to talk about the Fibonacci rectangle. The Fibonacci rectangle is a rectangle which is further divided into squares whose lengths are consecutive numbers of Fibonacci sequence. The proportions of golden rectangle are found in architecture as well as in art. It is pleasing to most people and is considered the most beautiful and most perfect ratio. In finding Fibonacci pattern in nature, kining Fibonacci rectangle is gamit yun kaayo. Mostly makita ni siya sa cyclone, sa mga shells ug uban pa. Fibonacci spiral. So para masabtan nato ang Fibonacci spiral, let us focus ourselves sa image nga ipakita sa right corner. This spiral is created by drawing circular arcs connecting the opposite corners of squares in Fibonacci rectangle. So mo nang ipakita sa picture. The numbers form what are called as Fibonacci rectangles. These rectangles are unique because each rectangle has length of sides equal to the magnitude of Fibonacci numbers. Within these rectangles, we can create a spiral with cross sections equal to exactly 1.618 or the golden mean, which with the corresponding angle of 137.5 degrees. Fibonacci in nature. There are infinitely many Fibonacci numbers that exist, and these numbers can be found everywhere in the world around us. So as what I've said kanina, Fibonacci can be found everywhere in the world. It can be found in the environment, can be seen in the physiology of plants and animals, or even in the human body. Now, I am going to show you some of the examples of Fibonacci numbers that can be found in nature. On many plants, the number of petals is a Fibonacci number. Buttercups have 5 petals, lilies and iris have 3 petals, some delphiniums have 8, corn marigold have 13 petals, and some asters have 21, whereas daisies can be found with 34, 55, or even 89 petals. Second example, Fibonacci sequence on pine cone. If we're going to count the number of spirals going from center of the cone to the outside edge, the resulting numbers are usually 2 consecutive Fibonacci numbers. I assure you that it will always be a Fibonacci number. Next, Fibonacci sequence in seashells. Seashells is some of the most common examples of the golden spiral in nature. The Fibonacci spiral directly corresponds to the spiral found in seashells. The spiral curve of the seashell follows the pattern of a spiral drawn in a Fibonacci rectangle. Fibonacci sequence can also be seen in the human body. We humans have 2 hands with 5 fingers, and each finger has 3 bones in it. The spiral curve of our ears follows the pattern of spiral drawn in Fibonacci rectangle. The same pattern can also be found in our fists. You can find examples and manifestations of golden ratio and golden spirals in countless places in your everyday life. Seashells, ocean waves, hurricanes, flower buds, snail shells, spider webs are some of the many naturally occurring examples. Many artists use the golden ratio and spiral in their creative works. From snail shells to flowers to bananas to the inside of the human ear, from the large iconic buildings to galaxies, the golden ratio can be seen everywhere. This is probably why it's also known as the divine proportion. There are so many places where you can find the golden ratio or the Fibonacci numbers that it is impossible to list all of them in one place and be done with it because the list is ever going. That ends my discussion of the Fibonacci sequence. I hope you learned a lot. Thank you.
The math concept discussed in our assigned video is all about Fibonacci sequence. What is Fibonacci sequence all about? In mathematics, the Fibonacci numbers, commonly denoted as Fn, form a sequence. In fact, the Fibonacci sequence in which each number is the sum of the two preceding ones. For example,
0 plus 1 equals 1, 1 plus 1 equals 2, 1 plus 2 equals 3, and 2 plus 3 equals 5, and 3 plus 5 equals 8, and 5 plus 8 equals 13, and 8 plus 13 equals 21, and so on.
First number of the sequence is 0 and the second number is 1, and each subsequent number is equal to the sum of the previous two numbers or the sequences.
The sequence follows the rule that each number is equal to the sum of the preceding two numbers.
The numbers in the Fibonacci sequence don't equate to a specific formula. However, the numbers fail to have certain relationship with each other.
Though found in many cultures, the sequences were named after Leonardo of Pisa, also known as Fibonacci, after he published a book introducing the sequences to the Western world.
Another interesting thing to note about the Fibonacci sequence is that it is closely related to the golden ratio, which is 1.618, which presented by this sign. The ratio of the sequential Fibonacci numbers approach the golden ratio. For example, 2 over 1 equals 2, 3 divided 2 equals 1.5, 5 divided 3 equals 1.667, 8 divided 5 equals 1.6, 13 divided 8 equals 1.625, and so on.
What is about these concepts cite few more real-world cases of example that would show the concept.
Numerous applications that have been made using the Fibonacci sequence. The Fibonacci sequence is used by computer algorithms including recursive programming approaches. Fibonacci helps data structures and Fibonacci search strategies. In the graphs called Fibonacci cubes, which are used to connect, distribute, and parallel systems. The Fibonacci sequence is also used. Fibonacci numbers are also employed by some numbers generators.
The Fibonacci sequence can also be found in nature, specifically in the number of petals. The following are the number of petals that is a Fibonacci number.
Buttercups have 5 petals. Lilies and iris have 3 petals. Some delphinium have 8. Crown marigold have 13 petals. Some asters have 21, whereas daisies can be found with 34 to 55 or even 89 petals.
We observe that many of natural things follow the Fibonacci sequence. It appears in a biological settings such as branching in trees, phyllotaxis, the arrangement of leaves on a stem, the fruit sprout of a pineapple, the flowering of an artichoke, an uncurling fern, and the arrangement of a pine cone's branch, etc.
What are your insights about the mathematical thoughts or certainties? My insight about this is we can only see math here in the environment, and sometimes we can only apply it every day, but it just depends on the situation.